Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. So we were doing this one in the last class, right?
Yes, ma'am.
Okay. So we can do this in more than one method. Did I just explain, or do you have the working to this question in your book? Children? Am I audible?
Yes, ma'am.
No, do you have the working to this question, the answer to this question in your book, or we have to still write down?
We have the working, ma'am.
You have the working.
Yes, ma'am.
Okay, so what's the value of x?
11 by 4.
11 by 4. Okay, so I told you that there in the working which you have in your notebook, we have taken 4 to the power, I guess 2x minus 2 common, right?
Yes, ma'am.
Here,
Yes, ma'am.
here, all this will be the same. All this will be the same. Maybe this I've written it as 384 itself. That's okay. This maybe I've written as 384. That is okay. Don't worry about all that. You can write it as 2 to the power 7 into 3 anywhere. Not that you must write it here itself. Okay. So don't worry about that. Now I think till here. So maybe you have 384. You have all these 3 steps.
Yes,
Please
ma'am.
look into your notebook. Yes. So the differences in the working which you have in your book, we have taken out 4 to the power 2x minus 2 common. Yeah. Okay. So now see here. So you can, I was telling you in the last class that you can even take out 4 to the power 2x minus 1 common. Either of the two you can take out as common. So now what happens when you take 4? So let me come from the beginning. So this is the question, or this is the equation. We need to solve this equation and find the value of x. So the first step is the base is 4 here. The base is 16 here. 4 and 16 should be brought to a common base. The common base for 4 and 16 is 2 or 4. The common base, both, okay, 4 can be written as 2 square. 16 can be written as 2 to the power 4. So 4 and 16 can be written with a common base 2. Or 4 and 16 can be written with a common base 4. 4 is 4 to the power 1 and 16 is 4 to the power 2. So you can write 4 and 16. You can choose the base. You can write them. You can write 4 and 16 in base 4 or base 2. Any one of the two. Okay, so I have written it in base 4. I have written it in base 4. So I have not made any change here. Please listen carefully. I have not made any change here. 4 to the power 2x minus 1 as it is. Minus 16 is 4 squared. So you can see 4 squared here. To the power x minus 1. To the power x minus 1. Is this understood?
Yes, ma'am. Yes, ma'am.
All right. Is equal to 384. I told you don't worry about this. This can be 384 everywhere till here. Don't worry. It can be everywhere. It can be only 384, or you can find the prime factors. You can find the prime factors. See here, the prime factorization of 384 to 1922, 9 18, 6 2, 48, 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. So 1, 2, 3, 4, 5, 6, 7 2s are there. So 2 to the power 7. 2 to the power 7 into 3, into 3, into 3, into 3. That's how we get 2 to the power 7 into 3. All of us will get the same thing. Maybe you have written it as 3 into 2 to the power 7. That can be the only difference. Either you write it as 3 into 2 to the power 7 or 2 to the power 7 into 3. Okay. I'll clear the slide because you know all this part you know well.
Yes, ma'am.
Yeah. So now 16 is 4 squared to the power x minus 1 is equal to 384. Then this one as it is, here we have to multiply the power. So you can see here I've multiplied the powers. 2 into x minus 1 is equal to 2 to the power 7 into 3. See, first you multiply. How do you multiply? 2 into x minus 1. Like this, you multiply the powers. Now next step, this one comes as it is. Here, 2 into x is 2x. 2 into minus 1 is minus 2. Is equal to 2 to the power 7 into 3. Now at this stage, we take out, last class we took out this common. Here we are taking out this one common. 4 to the power 2x minus 1 common. Now 4 to the power 2x, see now when you take out 4 to the power 2x minus 1 common, you need to write something here so that this into this will give you the first term. When you take out 4 to the power 2x minus 1 common, you need to write something here so that the product of these two will give you the first term 4 to the power 2x minus 1. But that itself is common outside. So I should write 1 here. And that's nothing but 4 to the power 0. I'll tell you. So now how do you multiply these two? We add the powers. So 4 to the power 2x minus 1 plus 0. So 4 to the power 2x minus 1. This into this will give us this term. This into this will give us the second term. See, that's what we do now when you have x cube minus x square y. You'll take out x square common and then what will you write? X square into x is x cube minus x square into y is x square y. When you take out something common, that common thing into x. So here x square is common. So x square into x will give us x cube. X square into y will give us x square y. Similarly, we have taken out 4 to the power 2x minus 1 common. So this one into this should give us the first term. And this into this should give us the second term. So that is what you should identify what to write inside. So now since here it is 4 to the power 2x minus 1 and that itself is common. So basically you should write 1 here because this into 1 will give you the same thing. But 1 can be, you can write 1 straight away. You can write 1 straight away. I have written 4 to the power 0 because when you multiply 4 to the power 2x minus 1 and 4 to the power 0, base are same. So you need to add the powers 2x minus 1 plus 0, which is 4 to the power 2x minus 1. Next, 4 to the power 2x minus 1 into what will give you the second term. You have minus 1 here. You need to get minus 2. See, 2x is there. 2x is there. What is common is what's outside is minus 1, but you need to get minus 2. So we know that minus 1 is minus 2. So you should raise 4 to the power. See, you can write anything inside. Just that the product should give you this one. This product should give you this one. And why are we writing base 4? Because the base is 4 here. Only then you can apply that. So if the base is 4 here, you should write in base 4 here also. Only then you can multiply. When bases are same and it's multiplication, you can add the powers. So whatever base 4 here, you should write the same thing here. So now 4 to the power 2x minus 1 into this, into 4 to the power minus 1. Base are same and it's multiplication. So we need to add the powers. 2x minus 1, 4 to the power 2x minus 2. So you get the second term. So do this for yourself, children. I've explained. This into this gives us the first term. This into this gives us the second term. How do we multiply? Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. So basically, this product should give you the first term. So how do you, when can you multiply? Only when the bases are same. That is why we write in base 4 here. then this product should give you the second term. And the bases should be same. So we write base 4. Supposing this was base 3 and base 3. So it'll be base 3 here. Then I'll write base 3 and base 3 here. Okay, so basically this product gives us this term. The law we are using is when bases are same and it's multiplication, we add the powers. Bases are same, it's multiplication, we add the powers. So I'll write it again here for you. 4 to the power 2x minus 1 into 4 to the power 0. Bases are same, it's multiplication, we add the powers 2x minus 1 plus 0. So we get that first term 2x minus 1, this one. Then we have to multiply this and this. Okay, this minus sign you can see here, minus. Then we have to multiply these two. So 4 to the power 2x minus 1 into 4 to the power minus 1. Bases are same and it's multiplication. So we have to add the powers, write the base as it is, add the powers 2x minus 1 minus 1. So 4 to the power 2x minus 2 is the second term. So like that, and then is equal to this one as it is. Now this as it is here, 4 to the power 0 is 1 minus 4 to the power minus 1 is 1 by 4. 4 to the power minus 1 is 1 by 4. Did I tell you the rule? Reciprocal of the base, negative of the power. Did I talk about that?
Yes, ma'am.
Yes, ma'am.
Yeah.
Ma'am.
Yeah. So how do we write the equivalent? Reciprocal of the base, negative of the power. Reciprocal of the base. The reciprocal of the base 4 is 1 by 4. So the reciprocal of the base 4 is 1 by 4. Negative of the power minus 1 becomes plus 1. So 1 means power 1 means you can just leave it. You don't have to write it. When the power is 1, you don't have to write it. So this is common. This is 1 and this is 1 by 4 is equal to this one as it is. Now 4 to the power 2x minus 1. 1 minus 1 by 4. All of us know is 3 by 4. Take the LCM. 1 minus 1 by 4 is 3 by 4 is equal to this one as it is. Now this 3 by 4 will go to the other side as 4 by 3. This 3 by 4 will go to the other side as 4 by 3. So children, till here you can write 384 if you want. Till here you can write even 384. Don't worry about that. Here also you can write 384. You will realize that you have to, find the factors at some point. You can write 384 till here also. So now into 3, so 3 by 4 comes to the other side as 4 by 3. So 3 and 3 gets cancelled. Now we have 2 to the power 7 here. We have 4 here. And now this one is the base is 4. There is another law which you can use. When bases are same, you can equate the powers on either sides. When bases are same on both the sides, you can equate the powers. When bases are same on both the sides, you can equate the powers. So now you have base 2 and 4 here. So you should write this one also in base 2. Sorry, here we have base 4 here. So I've written it in base 2. We have base 4 here after cancelling these two. We have base 4 here. We have 2 here and we have 4 here. So we write everything in base 2. We write everything in base 2. We write everything in base 2. So 4 is written as 2 square. 4 is written as 2 square. This 4 is 2 square to the power 2x minus 1 is equal to 2 to the power 7. Here itself you can write 2 square if you want. So we are writing everything in base 2. We are writing everything in base 2. Okay, so 2 to the power. So when you have more than one power, we have to multiply the powers. So 2 into 2x minus 1. Multiply the powers. 2 into 2x minus 1 is equal to 2 to the power 7 into 2 square. So this becomes 4x minus 2. 4x minus 2. 2 into 2x is 4x. 2 into minus 1 is minus 2. Here, bases are same as multiplication, so we add the powers. Now, why did we bring everything to base 2? Only then you can use this rule, which says that when bases are same on either sides, we can equate the powers. See, in the LHS, you see an exponential form in base 2. In the RHS also, you see an exponential form in base 2. In the LHS and RHS, you see exponential forms in base 2. So when bases are same, you can equate the powers. So 4x minus 2 is equal to 9. On solving this, you get x is equal to 11 by 4.
Yes, ma'am.
Yes, children, please write on this. Just to make you feel comfortable, let me write 384 itself, because you may wonder, how do you know you should find the prime factor? So let me write 384 itself here. You can keep writing only 384. You can write 384. Just from the student point of view, I'm writing. So this is 384. This is 384, okay? So here you will cancel. 4 and 3, you'll get 3 ones are 3 ones are 2s are 8s are 128 you get. You get 128. See here you have 384 into 4, okay? Because this is 3 by 4, it will come here as 4 by 3. Here you have 384. When you cancel 3 and 384, you will get 128. So here you will have 128 into 4. Here you will have 128 and 4. And 128 and 4. 128 is 2 to the power 7. And 4 is 2 squared. Maybe here you don't change, you write this as 4 itself. 4 to the power 2x minus 1. So at this stage, you write everything in base 2. At this stage, you write everything in base 2. See here, this in base 2, 2 square. This one in base 2, 2 to the power 7. This one in base 2. Yeah, please write on like this. Done, children?
No, ma'am.
Yes, ma'am. Yes, ma'am.
Just a minute, ma'am.
Okay. Please write down with the corrections I have made.
Finished, ma'am.
Yeah. Done, children? Oh my God, I can't see anybody.
One minute, ma'am.
Thank you so much. Krishmika, no, not Krishmika. Shri Krishmi, last class, you had shared answers on WhatsApp with me in a different way. So, meaning you're not listening to the explanation, you're just trying by yourself. But again, no, I don't want to comment further. Please listen to the explanation. Don't try to work it on your own. I don't want to say anything further. I have something in my mind, but I don't want to say. It's not right. You have to listen to what is being explained in the class and write out in the way I explain it. All right, Krishmi, Shri Krishmi. Yeah, please do that. And when I'm explaining, don't try to write anything. All right, thank you. Children, write down this question. You don't have to write question number 8, first one and all that. You write your question number, whatever order you have in your book. If it is 10, write 10. For you, the question is important. Question number 8, subdivision 1 is not important for you. The question is important. Write down the question. If you tell me the factorization, okay, you do this. Factorize 6561 and tell me, children. Please do this. Rough work. You can see it is 3 to the power 8, but you find, I want one of you to tell me the steps.
Ma'am, completed ma'am.
Who's that?
Sindhu ma'am.
Asking to tell me what's the number here?
6,561 ma'am.
Yeah. What should I write here? 2, 5, 7. What should I write? 3. So I get here
2,187 ma'am.
2.
187 ma'am.
2187.
Yes ma'am.
Okay. Then again.
3. 729 ma'am.
Okay. Then
3. 243 ma'am.
Okay.
3.
Yeah.
81 ma'am.
Okay.
3.
Yeah.
27 ma'am.
Yes.
3.
Yeah.
9.
Yeah.
3. 3. And 3 1 ma'am.
Very good. So how many threes?
3 to the power 8 ma'am. 3 8
8 threes. So 3 to the power 8. Okay. So 3 to the power 5x as it is. I've written the question first. I've written the question again. I've written this equation here again. Now this is in base 3. Now base 3 cannot be written in any other base. It's in base 3. Okay, so write that as it is. Now now you have to decide in which base you'll have to bring all the numbers to. So you know that you can bring 81 to base 3. And when you find the factorize, when you factorize 6561, you can see that also can be expressed in base 3. So we write all the numbers in base 3. This is 3 to the power 5x. This one is 81, you know, is 3 to the power 4. You find out 81, 3, 27, 3 9s, 3 3s, 3 1s. So 81 is 3 to the power 4. 81 is 3 to the power 4. And that square, the square. This one, just now Sindhu told us it is 3 to the power 8. And this 3 to the power 2x as it is equal to 3 to the power 7. So we've brought all other numbers in base 3. So now here we have to multiply the powers. 4 into 2, 8. So we have 3 to the power 5x, 3 to the power 8 into 3 to the power 8 by 3 to the power 2x is equal to 3 to the power 7. So what do you have to do? When bases are same and it's multiplication, we add the powers. If it's a division, we subtract the powers. So write the base ones, write the base 3 ones, and add these powers 5x plus 8 plus 8. 5x plus 8 plus 8. And this is in division, no? So subtract that power, minus 2x. 5x plus 8 plus 8 because it's multiplication. So we add the powers. This one is in division. So we have to subtract. So minus 2x is equal to 3 to the power 7. Then on simplifying the power, we get 3x plus 16 is equal to 3 to the power 7. Now bases are same on both the sides, like 3 and 3 you can cancel. Don't cancel. I'm just showing you like that. So equate the powers. So 3x plus 16 is equal to 7. And on solving, we get x is equal to minus 3. Right on, children?
Ma'am.
Yes.
Good evening, ma'am. I'm Devadarshini.
Hi, Devdarshini. You just joined the meeting?
Yes, ma'am. Actually, I had a class, ma'am, so that I joined late. Before few minutes, I've joined and left, ma'am, due to network issues. But now my internet is clear, ma'am.
Okay.
Okay, ma'am.
Will this always happen, Devdarshini?
What, ma'am?
No. Will you always have a class around this time and you will be joining the class late?
No, ma'am. No, ma'am. Today alone, I had few minutes extra, ma'am. That's why.
Oh, okay, fine.
Yes, ma'am.
Done, children?
Yes, ma'am.
Devdarshini, take a screenshot of this one. Complete this.
Yes, ma'am.
Take a picture. You can write it later.
Yes, ma'am. Taken one.
This one.
Taken one.
All right.
Only two, ma'am.
Yeah, only two more. Yeah.
Okay, ma'am.
Yes, this is the next question, children. All right, children. So we are writing the earlier step, 7 to the power n plus 2. How do you get a result like this? The earlier step should have been 7 to the power n into 7 to the power 2. It should have been like this. It should have been 7 to the power n into 7 to the power 2. So then bases are same, 7 and its multiplication. We add the powers and we get the result as 7 to the power n plus 2, correct? Yes. So it's like writing the earlier step. It's like writing the earlier step. I'll tell you again. We have 7 to the power n plus 2. 7 to the power n plus 2. We're writing the previous step. When will you get a result like this? It should have been 7 to the power n into 7 to the power 2. So bases are same, 7. It's multiplication. So we add the power, 7 to the power n plus 2. So we write the earlier step. So 7 to the power n plus 2 is written as 7 to the power n into 7 to the power 2. Minus this minus as it is, minus 3 as it is. You can see 3 here. And 7 to the power n plus 1 is written as 7 into 7 to the power n into 7 to the power 1. Because n plus 1, right? 7 to the power n plus 1. So earlier step should have been 7 to the power n into 7 to the power 1. The earlier step. Bases are same, multiplication, we add the powers. N plus 1 is written as 7 to the power n into 7 to the power 1. Similarly, in the denominator, 20 as it is, 7 to the power n, nothing can be done with it. Write it as it is, minus 2 into 7 to the power n. So nothing can be done, write them as they are. This one, nothing can be done, write them as they are. So what did we do? In the numerator, we write 7 to the power n plus 2 and 7 to the power n plus 1 as 7 to the power n into 7 to the power 2. Bases are same. Multiplication, add the powers n plus 2. Here also 7 to the power n into 7 to the power 1. Bases are same, multiplication, add the powers n plus 1. So writing the earlier step. Now we have some simplification to do. So let's do that in the numerator. So we have 7 to the power n, write it as it is. The value of 7 squared is 49. Minus here, minus as it is. 3 into 7 is 21. 7 to the power n. You can write 21 into 7 to the power n also. Seven square is 49. 3 into 7 is 21. So we have 7 to the power n into 49 minus 7 to the power n into 21. Now we take up 7 to the power n common. Between these two, between this and this, there's a minus here. The separator is minus. Between this and this, 7 to the power n is common. Don't take out anything else common. Like meaning between 49 and 29, between 49 and 21, you have 7 common. Leave the numbers, don't disturb the numbers. Just take out 7 to the power n common. Between this one and this one, 7 to the power n is common. Write it out. So what will come in the bracket? 49 minus 21. 49 minus 21. Similarly, in the denominator, 7 to the power n is common between this one and this one. In the denominator, between this and this, minus is the separator. 7 to the power n is common. You cannot cancel it. I'm not cancelling it. I'm just showing you that 7 to the power n is common. So 7 to the power n. In the bracket, you will get 20 minus 2. So 7 power n gets cancelled. 49 minus 21 is 28. This is 20 minus 2, which is 18. On simplifying, you get 14 by 9. On reducing, using the tables of 2, you get 14 by 9. So very simple, just writing the earlier step. Earlier step. That's all. And between these two, and okay, first we write 7 square as 49, and 3 7s are as 21. After that, we'll have to take out common between these two. 7 power n is common. So you'll get 49 minus 21 in the bracket. Here also between this and this, 7 power n is common. Bring it out. 20 minus 2 in the bracket. Cancels. And further you understand. Write down, children. Done, children?
Done, ma'am.
Yes, ma'am.
Yeah, similar one. Try this one by yourself. Very similar. How do you write 5 to the power n plus 2?
5n into
5 to the
5
power
power
n
2.
into 5 to the power 2, ma'am.
Okay, let's do it together, no? 1 minute. Let's do it together. You tell me, I'll write down. Yeah, tell me. 5 to the power
n into 5 to the power 5 to the power 2, ma'am.
then minus
6 into 5 to the power n 5 to the power n to 5 to the power 1, ma'am.
very good. Divided by
30 into 5 power n minus 2 into
minus 2 into 5 to the power 5 to the power n to 5 to the power 1, ma'am.
next we'll simplify. If there are numbers, we'll multiply the numbers, then take out common. If there are numbers to be multiplied, we will multiply and then take out common. Okay. Now, in the this is one, see, this is one part minus, this is the other part. This is one part minus, this is the other part. So what is 5 squared?
25.
So it will be 5 to the power n into 25 minus
5n. Minus 6, ma'am.
what after minus? Minus
Minus 5n into 30, ma'am.
into 5 to the power n, not 5n.
Yes,
5n is this
5 to
one.
the
This is
power
5.
Yes,
5 to the power n into 30. 6 5s are 30. Divided by yeah, tell me, divided by
13 into 5 power n.
13 into 5 to the power n minus
5. 10 into 5 power n.
10 into 5 to the power n. Okay, now what is, now take out common. What's common in the numerator? Take out the same thing common.
5 to the power n.
5 to the power
Yeah,
n.
take out the same thing common in the numerator and denominator. 5 to the power n. So what will come in the bracket?
5. 5. 25
25 minus 30.
25 minus 30 divided by
5 to the power n.
5 to the power n. 13 minus 10. 10, ma'am. Minus 10.
now.
5 to the power n gets cancelled, ma'am.
Yeah.
Minus 5 by
Minus 5 by
3.
minus 3.
Write down. Write down this, children.
Completed, ma'am.
Yeah. Done, all of you?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So in questions like this, the idea is we take the same thing common in the numerator and denominator. What is the least power? See, here it is not bases are same, add the powers because the sign is plus minus. See, we use the rule only for multiplication and division. See, if it was 2 to the power 30, if it was 2 to the power 30 into 2 to the power 29. If it was 2 to the power 30 into 2 to the power 29, then we say bases are same. Add the powers 30 plus 29. When it is 2 to the power 30 minus 2 to the power 29, there is no law here. When in exponents, when the connector is a plus or a minus, there is no law. For 2 to the power 30 plus 2 to the power 29, you cannot say bases are same, so I'm adding the powers. No. When it is multiplication, you add the powers. When it's division, you subtract the powers. Laws of exponents are for multiplication and division. See, 2 to the power 30 into 2 to the power 29. Bases are same. It's multiplication, so we add the powers. 2 to the power 30 divided by 2 to the power 29. Bases are same. It's division. We subtract the powers. If it's multiplication, we add the powers. If it is division, we subtract the powers. But here there is no multiplication or division. It's addition subtraction. So there is no law here. It's addition subtraction. Don't write the base once and add all the powers. 30 plus 29 plus 28. This is wrong. Now, of all these powers, which is the smallest power? 30, 29, 28, 31, 30, 29. Which is the smallest power?
28.
28.
Man.
See, again, I'll tell you, this sum can be done in 6-7 ways. You can take out anything common. That's what it is. But I'm just telling you something. So I'm taking out 2 to the power 28 common. I'm giving you a reason for that. Because that is the least power. You can even take out 2 to the power 29 common, 2 to the power 30 common, 31 common. In fact, 32 also you can take out common. I am taking the least power common. Okay. Okay, so writing the question first, 2 to the power 30 plus 2 to the power 29 plus 2 to the power 28 divided by 2 to the power 31 plus 2 to the power 30 minus 2 to the power 29 is equal to I'm taking out 2 to the power because I look at the numerator and the denominator. In both I compare and I see that 28 is the least power. I take out that common. Now 2 to the power 28 into what will give you 2 to the power 30? 2 to the power 2. Very good. 2 to the power 2. 2 to the power 28 into what will give you 2 to the power 29?
2 to the power 1.
2 to the power 1.
Plus 2 to the power 28 into what will give you 2 to the power 28?
1.
2 to the power 0, ma'am.
2 to the power 0. Yeah, very good. 1 is also correct. Now here also we'll take out the same thing we'll take out common, I'm saying, so that I can cancel these two. That's the reason. That's the reason. What should I write here?
2 to the power 3. 2 to the power 3. 2 to the power 2, ma'am. 2 to the power 1.
2 to the power 1.
See, children, here you're multiplying 2 to the power 28 into 2 square. 2 to the power 28 into 2 square. Bases are same and it's multiplication. So we have to add the power. So you will get 28 plus 2, 30. You get the first term. 2 to the power 28 into 2 to the power 1. 2 to the power 28 into 2 to the power 1 is equal to, base are same, it's multiplication, add the powers, 2 to the power 29. See here, you're getting the second term like that. Now this gets cancelled. So what do you have in the bracket? What is 2 square?
4.
4.
2.
2. 1, ma'am.
8. 8. 4.
4.
Minus 2.
Minus 2, ma'am.
Now don't cancel 2 and 2. Add the numerator. Don't cancel 4 ones are 4 twos are. Don't. You cannot do that. 4 plus 2, 6. 6 plus 1, 7.
7 by 10.
8. Sorry, 12 minus 2, 10. 7 by 10. It's the same method. Yeah, you can copy this. Exactly what I explained, children. You can write down this.
Completed, ma'am.
All right. All of us?
Completed,
No,
ma'am.
ma'am.
Completed.
Um,
I'm doing.
Okay.
completed. Completed, ma'am.
All right, children.
Completed, ma'am.
Try this by yourself. Take out the least power common. Which was the least power?
20.
3.8.
20.
28.
Yeah. Do it in the same way. I'll just get back in 2 minutes. Done, children? What's your answer?
Yes, ma'am. 13 by 30.
13 by
13 by
30.
30.
Yes, ma'am. 13 by
13 by 30, yeah?
13 by 33. 13.
33. Okay, 13 by 33. All of us are getting the same answer. Very
No,
good.
I'm getting 13 by 30.
13 by 30 you're getting. Okay. Uh-huh. Okay, let's see the answer.
Yes, ma'am.
Maybe some addition error. What is 27 plus 9?
33.
27 plus 9 is 33, yeah?
No, no, no.
36.
Yes.
Yeah. If you've made some other mistake, please get your doubt clarified. I think you must
No,
have
ma'am.
gone there. 27 plus 9.
Yes, ma'am.
Okay. All right, children. This is what we finished now. Yeah. These are very common questions, mostly asked. Such questions are mostly asked. Very likely questions. Okay, let's see the first one. Now, the thing is, you need to make 3, you must make 3 minus 2 root 2 look like a perfect square. Only then you can get rid of the square root symbol. Now, when you have, say, square root of 25, square root of 25 is square root of 5 into 5 or 5 square. So it is nothing but 5. To get rid of the square root symbol, you need to make the expression under the square root a perfect square. If the expression under the square root is a perfect square, then you can get rid of the square root symbol. So we'll try to write 3 minus 2 root 2 as something the whole square. Like supposing you write 3 minus 2 root 2. Supposing you're able to write it as, I'm just saying for example, okay, something like a minus b the whole square. See, it can't be a minus b. There are numbers here. It can't be a minus b. I'm just telling you, if you write it as square root of a minus b the whole square, then the answer is a minus b, because under the square root you have a minus b 2 times. Like under the square root, if you have 5 square, from 2 5s, 1 5 comes out. So the value is 5. Similarly, under the square root, you have a minus b into a minus b. You have a minus b 2 times. So a minus b is the result. So here are, we're trying to express this one as a perfect square. To express it as a perfect square, we need to write it in the form a. This is very important. It may come with other numbers. It may come with other numbers. So the idea is important. It's not about the same question did not come in my exam. Any question using this idea can come. Any question where this idea has to be used can come. You cannot. So in different sums, we learn different ideas. These ideas you have to register. So even if you see a new question, from the various ideas you have, you'll have to think and do it. You should do it. You should be able to do it. So here the thing is, we are trying to write this one as a perfect square. 3 minus 2 root 2 as a perfect square. So now 2 root 2. 2 root 2 is like 2 into, it's very simple. 2 you cannot decompose 2 further. 2 is 2. See, supposing it was 4, I can write as 2 into 2. Supposing it was 4, I can write it as 2 into 2. It's 2. I can't do anything with it. Similarly, root 2. Root 2 also is very simple. 2 into root 2. So you can add 1 with it so that it looks like 2ab. So that it looks like 2ab. 2 into root 2 into 1. 2 into a into b. So this is 2. Okay, before that I should tell you the identity. You know this, but so a squared plus 2ab plus b squared. If you find these 3 terms, you can write it as a plus b the whole square. A square minus 2ab plus b square. If you find these 3 terms, you can write it as a minus b the whole square. Are these identities new to you?
No, ma'am.
No.
No, ma'am.
Yeah. This is of 8th standard. You're already familiar. You're aware of these identities. So if you have to write something as a plus b the whole square, you should have a square term, 2ab term, and b square term. A square plus 2ab plus b square. If you have terms like this, you can write it as a plus b the whole square. If you have terms like a square minus 2ab plus b square, then you can write it as a minus b the whole square. See, the only difference is with the middle term, 2ab term, plus 2ab minus 2ab. Otherwise, a square is plus, b square is also plus only. In both a square, plus b square, plus b square, plus 2ab minus 2ab. That's the difference. That makes it a plus b the whole square and a minus b the whole square. Same, different. So obviously here we have a minus. So mostly it should be a minus b the whole square. This is minus here. So it should be a minus b the whole square. So now see here, when you identify the 2ab term, I have to talk in length. Please have the patience to listen. So when it's 2a, when you find out the 2ab term, you know the a and b in them. So I say 2 into root 2 into 1. So that means your a is root 2 and your b is 1. Sorry. I repeat, 2 root 2. 2 into root 2 into 1. 2 into a into b. So a is root 2, b is 1. A is root 2, b is 1. A is root 2, b is 1. So now what we do is we write 3. We write so root of 3 minus 2 root 2 is equal to root of, we write 3 as 2 plus 1. 2 plus 1 is 3 minus 2 root 2. Now this is equal to root of 2 plus 1 minus 2 into root 2 into 1. From this, I'm able to make out that root 2 is a and 1 is b because 2ab. So a is root 2, b is 1. So I must make this look like, I must make this one look like a square. This one look like b square. And I have my 2ab here, minus 2 into a into b. So this is only your a, right? So this is a. And this is your b. This is your b. What is root 2 squared? 2. What is 1 squared? 1. So you can see a square, you can see plus b square, you can see minus 2ab, which is nothing but a minus b the whole square, root 2 minus 1 the whole square. So the value of the expression is root 2 minus 1. Root 2 minus 1 the whole square under the square root. So the value is root 2 minus 1. We'll do it again. Slowly we'll do it again. The given expression is square root of 3 minus 2 root 2. There is an expression under the square root. So you want to make the expression a perfect square so that you can get rid of the square root. So you start like this. When we start, we don't know what to do, no? So we write 3 as it is. How do we know that I should write 3 as 2 plus 1? So I write innocently, I write 3 as it is. Minus, I can see the 2 there. So I want to write it as 2ab. 2 into a into b. A into b. 2 into a into b, 2 into root 2 into 1 is 2 root 2. So I understand that a is root 2 and b is 1. So since there is root 2 and 1, I get the idea that I should write 3 as 2 plus 1. See, you can write 3 as 5 minus 2 also. You can write 3 in different ways. You can write 3 as 10 minus 7. Why 2 plus 1? Because A is root 2 and B is 1. So somewhat you want to get the 2 and 1. Then only you can get root 2 and 1. So you write 3 as 2 plus 1. And that minus 2AB as it is. Now you want 3 terms here. 1, 2, 3 terms we got. I should make this 2 look like a whole square. Something the whole square. A square plus B square minus 2AB minus 2 into A into B. A into B. So A is root 2. B is 1. And see, root 2 square is 2. 1 square is 1. So we have A square, A the whole square plus B the whole square minus 2AB, which is nothing but A minus B the whole square. A, this is A minus B the whole square. So we have made that expression a perfect square. So that means under the square root you have, under the square root you have root 2 minus 1 2 times. Square root of, you have root 2 minus 1 into root 2 minus 1. 2 times you have. So how will you get rid of the square root? Bring out 1 root 2 minus 1. This is the answer. Write down, children.
Completed, ma'am.
All right.
Completed, ma'am.
All right.
Completed, ma'am.
I think the next one. Tell me what is 128? Meaning, how do you express 128 in the exponential form? Yes, 128 in the exponential form. I'm not going to say anything.
Ma'am, 2 to the power 7, ma'am.
2 to the power 7. Very good. 128 is 2 to the power 7. But there's already that power minus 2 by 7. What should I do?
Brackets.
2 power 7 into minus 2 power minus 2 by 7.
So what should you do when there are many powers? You should
Multiply, ma'am.
multiply the powers. So 128 is 2 to the power 7, but there's already that minus 2 by 7. So multiplied by minus 2 by 7. Minus, what is 625 in the exponential form?
25 square.
5 to the power 4.
5 to the power 4.
4.
25 square, but 25 is not a prime number. No, you can write it as 25 square, but you have to again simplify in the next step. Use a prime factor as a base. Try to use a prime factor as a base. 25 is not a prime number. So 625 is 5 to the power 4. 625. 5, 125 times 5, 25 times 5, 5s are 5, 1s are. So 5 to the power 4. How many powers are there already? There is
3.
already one power minus 3. There is another power minus 1 by 4. What should you do with all these powers?
Multiply all, ma'am.
Multiply. 625 is 5 to the power 4. Multiply the remaining powers into minus 3 into minus 1 by 4. Plus 14 into, what is 2401?
7 to the power 4.
No, it is not clear, ma. Come again.
7 to the power 4, ma'am.
7 to the power 4. You already found it. Very good. 7 to the power 4. Correct. Because 2401 is equal to 7. 3s are 343. Okay. 7 49 times. 7 49 times. 7 7s are 7 1s are. You try by 2. It's not that why should you take only 7? Why you're not taking 5? It's not divisible by 5. You come from the beginning, from the prime factors from the beginning. 2 not divisible, 3 not divisible, 5 not divisible. So then when you try by 7, it is divisible. 2401 is divisible by 7. It's not that we are taking 7 by choice. 2401 is not divisible by 2, is not divisible by 3, is not divisible by 5. And when you try by 7, it's divisible by 7. So it is 7 to the power 4. 14 into 7 to the power 4. But there's another power, no? Into minus 1 by 4. Is this correct? Is the first step understood?
Yes, ma'am.
Okay. Then what's the next step? What will get cancelled?
7, 7.
7 and 7.
Okay, then what will remain? 7 and 7 will get cancelled. So 2 to the power?
Minus 2.
Minus 2, ma'am.
Okay. Minus. What gets cancelled here?
4 and 4.
4 and 4. So what will remain? What's
3.
the power?
Plus
3. 3 plus 3.
Because minus 3 into minus 1 is plus 3. Minus 3 into minus 1 is plus 3. Then you should not multiply 14 into 7 now. Plus 14. What do you get? 4 and 4 will get cancelled, right?
Minus 1.
So it will be into 7 to the power minus 1.
Minus 1, ma'am.
7 to the power minus 1. So next step, what is 2 to the power minus 2?
1.
1.
2 by 2.
1 by 2 to the power 2, ma'am.
What's the reciprocal of the base?
1 by 2, ma'am.
By.
And the
What's the negative of the power?
2, ma'am.
2.
You can write whole power 2 also.
Yes, ma'am.
Anything. Reciprocal of the base. Negative of the power. Minus what is 5 cube?
125.
125, ma'am.
125.
What
1
is
by
7?
7.
1 by
1 by
7.
7.
1 by 7, ma'am.
Yeah.
1 by 7.
1 by 7. What is 1 by 2 the whole square?
1 by 4.
1 by 4, ma'am.
1 by 4, ma'am.
Now 7 1s are 7 2s are.
Yes,
So
ma'am.
what is it?
Plus 2.
Yeah, now simplify this. 1 by 4 minus 123. Take the LCM and get the answer.
Ma'am?
Yeah.
Ma'am, the answer is minus 491 by 4, ma'am.
491, right?
Minus 491 by 4, ma'am.
Correct. Correct. All those X sums, did you complete writing in your notebook?
Yes, ma'am.
Done, all of you?
Yes,
Yes,
ma'am.
ma'am.
Ma'am, I didn't, ma'am. Can you please switch it?
Done, Pradit?
Yes, ma'am.
Children, take a screenshot. You will be able to understand. Complete this one. Very important question from test exams point of view. When the power is negative, if you change the position, that is, it's in the denominator. When you take it to the numerator, it will become positive. So 3 to the power minus 3, when you take it up to the numerator, it will become 3 to the power plus 3. Two to the power minus 5. When you take it up to the numerator, it will become 2 to the power plus 5. You can do it like this, or straight away apply the law. When base are same and its division, we subtract the powers, right? 3 and 3, base are same, its division, we subtract the powers. Here also you can write it as 2 squared, and then base are same, its division, you can subtract the powers. 5, 5, base are same, its division, you can subtract the powers. You can do that way also. All right. All children's time, so.
Thank you, ma'am.
I can see only 3 of you. Sanjay, Sindhu, Prajakth, Netra, now Tanishka and Raja. Krishmika, Krishmi, Arjun. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.